In the first part of this tutorial we will show you how to build a model in EINSTEIN for the present state and to check for consistency and completeness. First of all, we create a new project. Project, new, and we call it demoTFC. We will fill in some general data of the project. Period of operation. The company operates in 12 hours a day in one shift during 365 days a year. We suppose that the plant produces only one product and we do not know the quantity produced. And finally, we want to specify the operation and maintenance costs for the heating and cooling supply system in present state. We fix a number of 0. It is supposed that the real costs for the existing equipment remain constant for all possible alternative scenarios and therefore do not have an effect on potential savings. Now we add a process to the system which is generating waste heat. Adding a process is done by right-clicking on the free space in the system scheme. Waste heat is available in form of cooling water, so we add to residual energy an outflow, and we call it cooling water at a temperature of 90 degrees and a flow rate of 30,347 kilogram per hour. The medium is water. This process has also a heat demand of 2,649 kilowatt at constant temperature. So we add a maintenance heat demand and specify the power. And the temperature. We suppose that the heat transport medium can be directly used within the process without need for a heat exchanger, so that the minimum temperature difference between heat supply medium and process medium is 0. With regard to the operation schedule of the process, for the moment we keep the default values. 12 hours in one cycle per day during 365 days a year. This will be modified later on. We confirm the information we entered by clicking OK. Now we add a second process consuming low pressure steam. Again, we right-click on the system scheme and select Process. Heat demand now is composed by two parts: the sensible heat for preheating water to the evaporation temperature and the latent heat for evaporation. First we enter the preheating part, adding an inflow to the process. The flow rate is 2,617 kilogram per hour and an inlet temperature of 60 degrees. minimum temperature is 0 and the process temperature is 120.5 degrees, which is close to the evaporation temperature. Then we enter the power required for latent heat. As a maintenance heat demand, the power is 1600 kilowatt. And as before, we accept the default operation schedule of 12 hours per cycle and 365 days per year. And we confirm by OK. A third heat demand is given by the space heating requirements of buildings. Building heat demands, unlike other heat demands, are not directly defined as processes, but indirectly by adding a building to the system. Go to the main menu, Buildings, and we add a new building. The building is supposed to have only one demand for space heating and none for air conditioning or domestic hot water. The heating demand is 4000 megawatt hours a year. The required temperature for the heating system is 55 degrees and the target temperature for the indoor is 20 degrees. The occupation of the building is 12 hours a day during 365 days a year, and the heating period is supposed to be from October to March. We confirm the data by OK, and after having added the building, we can see that a third process has now been added to the system, describing the building space heating. For the heat supply to the processes, we add a steam boiler to the system. Select Equipment. And call it steam boiler. So nominal power output is 10 megawatt and the conversion efficiency is supposed to be 0.9. The boiler is fired by natural gas. Therefore, we add a fuel natural gas to the system and connect the fuel as input to the steam boiler. A steam piping is required in order to supply heat from the boiler to the processes. So we add a piping. We suppose a closed loop with 100% recirculation, a forward temperature of 180 degrees, and a return temperature of 80 degrees. The heat transport medium is steam at 10 bar pressure. And the length of the piping is defined as 800 meters. Now we connect the steam boiler to the input of the steam piping. And the output of the steam piping to the input of the first two processes. Space heating is provided by a separate boiler. We add an additional equipment, a hot water boiler. We select the type, hot water boiler. Give a name to it. So the nominal heating power is 4 megawatt. And the efficiency also here is supposed to 0.9. Although this boiler is fired by natural gas, so we build the corresponding connection. Heat is distributed in a hot water piping. The fluid is water, in this case. So forward and return temperatures are 70 and 50 degrees respectively. And also here fully closed circuit is supposed. And the length is specified as 10,000 meters.